Let's go ahead and do another example of finding the greatest common factor, or GCF. So this time we're going to find the greatest common factor of 15 and 26. So just like before, we're going to put these numbers into a factor tree. So 15 splits up into 5 times 3. Now 5 and 3 are both prime numbers, so 15 cannot be split up any further. So let's go ahead and check out 26 now. So 26 we know is 13 times 2. 13 and 2 are both prime numbers, they cannot be split up any further. So if we go over to the side here, then what we have is 15 equals 1 times 3 times 5, and 26 equals 1 times 2 times 13. 1 times 2 times 13. Okay, now, just like before, what we do is we look and see, do these two numbers, 15 and 26, have any factors in common? Well, here's a factor of 1 they have in common. 15 has a factor of 3, 26 does not. 15 has a factor of 5, 26 does not. Similarly, 26 has a factor of 2, 15 does not, and 26 has a factor of 13, 15 does not. So actually, the only factor these two guys have in common is the number 1. So then the GCF is just 1, which is actually another way of saying they don't have any factors in common. So the phrase for this is these two numbers are relatively prime. If the greatest common factor of two numbers is 1, then the numbers are said to be relatively prime. So 15 and 26 are relatively prime. Just a little side note there. And remember, a couple videos ago, we said we're going to write this 1 down here, even though it's not in the factor tree. We're going to put the 1 here just in case. And this is why we do that, just in case the numbers don't actually have anything else in common besides the 1. So anyway, that's this example here. 15 and 26, greatest common factor is 1.